Alright, so here we have the first question from the topic of moment of force from the most recent past paper, one of the most recent past paper 2023, paper 2-1 May June. And that is question number 2, by the way, from that paper. So let's start this one. A rigid uniform beam of weight W is connected to a fixed board by the hinge, as shown in figure 2.1. Then you have the diagram given. It is not to scale, means you cannot just figure out the distances or stuff like that just by taking the measurements from the ruler. Then you have the description. It is just the same thing that is given in the diagram, so I'm not going to read this one. The beam is in equilibrium. So what we mean by this is we can easily apply the principle of moment. We can safely apply the principle of moment. Assume that the hinge is frictionless. The first part says show that the vertical component of the tension in the string is 2.4 Newton. So where's your string? First of all, this is your string. It has two components. One of the component would be in this direction. The other component, the vertical one, would be in this direction. So you see your string is, the tension in the string is towards the bottom right corner. One of the force would be towards the right side. One of the force would be downward. And the component of the force that is there with the angle is your x component, or 4.8 cos theta. ठीक है, जो डायरेक्ट एंगल के साथ आपका बन रहा होता है, we use cos theta with it. And the other one, obviously, that would be sin theta. So 4.8 sin 30. Okay, sin 30 is, by the way, 0.5. So what you write is 4.8 times sin 30 here, which means 4.8 times 0.5. And the number would be reduced to half, 2.4 Newton. So this would be the answer to the first one. Okay, kind of an easy question. So then we have the next one. That is the detailed question. By taking moments about the hinge, determine the weight W of the beam. So you need to apply the principle of moment in this one. So the force exerted by the beam, by the spring is 8.2 Newton vertically upward. Okay, given in the very first sentence. So here we have a force of upward, a force of 8.2 Newton upward. So how many forces do we have about this pivot? One of the forces is this one, which is upward, 8.2. The other force is W, which is downward. The third force is 0.30 Newton, which is also downward. And the force of 4.8 Newton, that is not perpendicular to the distance. We will consider only a component of that force which is perpendicular to distance. और इस force का जो component perpendicular to the distance from pivot है, that is this one component, which is, इसको calculate हमने कर लिया था, this was 2.4. So we can use the force 2.4 Newton downward straight away. Now we can mark the forces which would rotate it clockwise and the forces that would rotate it anti-clockwise. So this one anti-clockwise, ठीक है, यहाँ से आपका spring इसको ऊपर को push करेगा, this would be anti-clockwise. W would be clockwise, it would turn in this direction. 0.30 Newton would also be clockwise in this direction. इसके साथ भी C लिख देते हैं. And the last one, 2.4 Newton, which is downward, would also be clockwise. It would also move the beam in this direction. Let us apply the principle of moment. So यहाँ पे top पे मैं इसकी description लिख देता हूँ. So first, let us add the anti-clockwise forces on one side because we have a single one. So ये आपकी हो जाएगी 8.2 times the perpendicular distance of that force from the pivot, which is 0.5. So 0.50 equals, how many forces do we have clockwise? W W को red से लिखते हैं because we need to find the value of W. W times what is the perpendicular distance of W from the pivot? It is this much. What is 0.60? So 0.60 plus there's another force that will rotate it clockwise, 0.30. So 0.30 times is force का perpendicular distance from the pivot, 0.6 plus 0.2, which would be 0.8. So 0.3 times 0.8 plus the last one is 2.4. 2.4 times the perpendicular distance of that force from the pivot. तो तीनों को ऐड कर लो. I mean all four of them. तीनों को नहीं, all four of them. 0.50 plus 0.10 plus 0.20 plus 0.40. What do we get? We get 1.2. So you need to do some simplification from here. आपने लेफ्ट साइड को सॉल्व करना है, राइट साइड को सॉल्व करना है. Thus subtract these two, divide the answer by 0.60. You'll be getting the value of W. ठीक है, यहाँ से simplification. I'm not going to do the simplification. You can do it by yourself. The answer for W in 2SF, because the raw data, the entire raw data was in 2SF, so our answer should also be in 2SF. वो आपके पास आ जाएगा. Let's take a look at the next one. The last part of it, calculate the horizontal component of the force exerted on the beam by the hinge. Force exerted on the beam by the hinge. That force in this case equals to the horizontal component of tension in the string. 4 point. First of all, you can write it as Fx, and that equals to F cos theta. 4.8 times cos 30. Then you hit it on the calculator, you get 4.2. And matter of fact, it should be easy because you have only a single force that is horizontal, and that is also a component of this force. इसके अलावा आपके पास कोई ऐसी force है भी नहीं which is directed horizontally, so it should be very obvious one. Alright, so here we have the second question from 2023 paper 2-2 May June. The part A says, state what is meant by the center of gravity of an object. So this is how we define this one. The point where the entire weight of an object appears to be acting. This is our center of gravity of the object. Let's take a look at the part B. Two blocks are on a horizontal beam that is pivoted at its center of gravity as shown in figure 2.1. Okay, so what do we need to find? आपको find करनी है the value of T. So let's check out how many forces do we have. Okay, let's start with this one. Let's check out the forces that are there on the beam. आपके पास first one force है 54 Newton. There's another force which is 2.4 Newton, and this has to be considered as a pivot. So we do have the perpendicular distance of first force from the pivot. We do have the perpendicular distance of the second force from the pivot, but the third force, for the third force, that is T newtons, we don't have this force perpendicular to the distance from pivot. So आपको इसको components में resolve करना पड़ेगा. Either you need to resolve the distance into components or this force into components. So the better would be that you resolve the tension T into perpendicular components, and you consider the component of this force that becomes perpendicular to the distance from the pivot. So one of the component of this force would be over here. So one of the component you can draw towards the right side, and one of the component you can draw downwards. So these are the two components of that force T. So what do we call the horizontal component? We call it T cos theta. T cos theta. The component that is directly there with the angle, उसको हम cos theta से represent करेंगे. So T times cos theta, ये आपके पास इस force T का horizontal component आ जाएगा. Then we have this one. t sine theta, because this component is not directly with the angle theta, तो ये आपका होगा t sine theta. Now which one of these two components, for which one of these two components we do have the value of perpendicular distance? Think about it. This is your pivot, this is your axis of rotation or line of pivot, this is your line of force. If we consider the downward force t sine theta, then we do have the perpendicular distance of that force from pivot, which we can find by adding these two. So matter of fact, we'll be taking the downward force, the component that is downward, for the calculation of moment. और once again ये आपका component कितना था, t sine theta. t sine theta means t sine 30 because angle is 30. So ये आपके पास आ जाएगा 0.5, sine 30 is 0.5 times t. Now let us apply the principle of moment about this point. Pivot के around या pivot के about we apply the principle of moment. What is the force that would rotate it clockwise, and what are the forces that would rotate it anti-clockwise? So this one would rotate it anti-clockwise in this way. ये वाली rotate करेगी clockwise, so you can write c with it. This one would also rotate clockwise, you can write c with it. So let us apply the principle of moment. So 54 times the perpendicular distance of net force from the pivot, which is 0.45, and that equals to clockwise side पे आपके पास क्या है, first you have 2.4 times the perpendicular distance of that force from the pivot, which is 0.95, plus, because it's another force that will rotate it clockwise, which is one of the component of t. और कितना है आपके पास force was 0.5 t, and the perpendicular distance of that force from the pivot is 0.95 plus 0.35. Final answer that you'll be getting in 2SF would be 34. So 34 would be your final answer for this one. Okay, let's take a look at the next one. The string is cut so that the beam is no longer in equilibrium. So the string is not there, the tension in the string would not be there, so one of the four goes out the window. ठीक है, एक जो आपकी फोर्स थी वहाँ पे जो कि उसको इक्विलिब्रियम में मेंटेन करने में हेल्प कर रही थी, दैट इज़ नॉट देयर. सो क्लॉकवाइज एक साइड पे जो आपका क्लॉकवाइज मोमेंट था वो थोड़ा सा कम हो जाएगा आपका. Calculate the magnitude of the resultant moment about the pivot acting on the beam immediately after the string is cut. So देखो, this was the thing. What was the moment of force produced due to the string? वो ये वाला portion था आपका. This one. This is the moment that is produced due to the string. And if this is not there, आप इसको zero कर दो. So let's see what happens now. What is the moment of force that we have on the left side? ये आपके पास हो जाएगा 54 times 0.45, which is 24.3. तो anti-clockwise आपके पास आ गया 24.3. And what do we have clockwise? वो भी calculate कर लेते हैं. Now we have only 2.4 into 0.95. That's it, 2.28. So 2.28. We can subtract these two, and what do we get? 24.3. We get 22.02. So in 2SF we can write it as 22. So 22 Newton meter is the clockwise moment of force. That is the resultant moment. Okay, so for question number 3, which is from paper 2-3 of 2023 May-June, you're provided with a diagram, not on scale. Description में लिखा हुआ है the system is in equilibrium, means we can apply the principle of moment if we have to. So the first question was two conditions for the object to be in equilibrium. These are the two conditions that you can memorize and write it as it is. ठीक है, short form में लिखा है, but you'll get 2 marks if you write it in this way. No resultant force in any direction, no resultant moment of force about any point. So the part B says, show that the vertical component of the tension in the string is 13 Newton. So where is your string? This is your string. And you need to show the vertical component, or vertical component होना चाहिए आपका 30 Newton. So very easy one. You can make two perpendicular components of this force. On matter of fact, let's just make vertical one. We won't even need the horizontal one, at least for now. So ये आपका हो गया इस force 70 Newton का vertical component. So mathematically this would be equal to the force times sine theta, because it is not directly with this 50-degree angle. जो नीचे वाला आपका horizontal component होगा वो होगा 70 times cos theta, but this one would be 17 times sine theta. So 17 times sine theta, we can hit it on the calculator. Okay, then we have the next question. By taking moments about the end A, calculate the weight W of the beam. Once again, an easy one. We can apply the principle of moment because the system is in equilibrium. ठीक है, ये भी given है in the very first sentences of the description. So let us apply the principle of moment. और किस point पे apply करने? About the point A. So this is your pivot. So if this is your pivot, you can mark the forces जो इसको clockwise rotate करेंगे and the forces that will rotate it anti-clockwise. For example, this one would be clockwise, this one would make it rotate clockwise, and the last one would be anti-clockwise. And the last force that you consider for the moment of force would be F sine theta, which is one of the component of the 70 Newton force. We don't take 70 Newton force because the force 70 Newton, for that force you don't have the perpendicular distance from the pivot. So या तो आपको फिर distance को resolve करना पड़ेगा in components, and then you'll need to figure out कि उसमें से कौन सा distance इस force के perpendicular आएगा. But then at the same time, it would be easier that you already have resolved this force into a component, and this is exactly the component for which you do have the perpendicular distance from the pivot. So this is, see, this is your line of pivot, this is your line of force, and you do have the perpendicular distance between these two, for which you can add 0.35 and 0.15. So I'm going to apply the principle of moment. Clockwise हमारे पास एक W है, so W times, you see the total length of the beam is 0.50, and since this is a uniform beam, yeah, it's written over here, because this is a uniform beam, so the weight would be exactly in the middle point or in the midpoint. So 0.5 is the total length, so weight किस point पे होगा? 0.25 पे. Half of 0.50 would be 0.25. Plus there's another force जिसकी वजह से clockwise moment of force produce होगा. That force is 12 Newton, so 12 times, what is the perpendicular distance of that force from the pivot? 0.35. And the sum of clockwise moments equals the sum of anti-clockwise moments. So what is the anti-clockwise force? That is F sine theta. और इसको solve भी कर लेते हैं. What do we get for F sine theta? We get 17 times sine 50. This is the value of F, this is the value of theta. So F sine theta आपके पास आ जाएगा 13. So 13 times, what is the perpendicular distance of that force from the pivot? 0.50. Okay, all of it, you can add both of them, you'll be getting 0.50. From there you do simple mathematics. इसको आपने solve कर लेना है, just hit it on the calculator and find the value of W, और W की value आपके पास आ जाएगी 9.2. So 9.2. Okay, I'm not showing the working here. आपने इसी part में space में show करनी है, but I've shown it over there with the diagram. Okay, then we have the next one. Calculate the magnitude of the vertical component of the force exerted on the beam by the hinge. Magnitude of the vertical component of force exerted on the beam by the hinge. So what we can do is we can find the resultant vertical force, or the resultant of the vertical forces. How many vertical forces do we have? Let's check it out. Two of them are here. One of the force is W, that is downward. One of the force is 12 Newton, that is downward. One of the force is there, which is the component of the force 17 Newton. और ये component आपके पास कितना आया था? 13 Newton. So I'm going to write 13 Newton here. So you have two forces downward, one force upward. You have the values of all these three forces because W की value भी अभी आपने find कर ली हुई है. So what is the total force downward? We have W plus weight of the block plus weight of the beam. So 9.2 plus 12 Newton. And there was an upward force, उसको हम subtract कर लेंगे इसमें से, which was 13 Newton, which is one of the component of the force in the string. And what do you get as the final answer? You get 8.2. To SF you get 8.2. Okay, then we have the next one. The block is now moved closer to end A of the beam. Assume that the beam remains horizontal. State whether this change will increase, decrease, or have no effect on the horizontal component of the force exerted on the beam by the hinge. So block is now moved closer to the end A. So you see, if you move it closer to the end A, you're moving it somewhere over here, the overall effect of this force would decrease. The closer it is to the pivot, the less effective it would be in this situation. And we don't need to explain it. ठीक है, उसने आपसे सिर्फ state पूछा है, means you just need to write would it increase, would it decrease, or have no effect. So ladies and gentlemen, that's it for today. That's for this video. Don't forget to subscribe the channel. Also, if you like my work, you can support me on Patreon. The link is in description. Also, for this one worksheet, you can download it from the link that I've provided in the description.